Welcome to our deep dive. Today we're going to be looking at how AI is changing the way we manage complex tasks. It's a pretty fascinating area of research, and the paper we'll be focusing on today is semantic-driven task allocation, elevating multi-agent systems with language models. It's by Remen Marizao, and it was published just recently on December 31st, 2024, so very cutting-edge stuff. Essentially, Marizao is proposing that we can use AI language models, these LLMs everyone's talking about, to make teams of computer programs way smarter and more adaptable. These teams are called multi-agent systems, or MAS for short.
That's right. And a lot of these systems today, they rely on what we call static task allocation. It's like, imagine you've got a team of robots building a house, and each one is assigned a specific task from the get-go. But then what happens if something changes? Like, let's say there's a material shortage. With static allocation, the system can't really handle that.
Right. It's like they're stuck with the original blueprint no matter what happens in the real world. And we all know the real world is, well, rarely that predictable.
Exactly. Things are constantly changing. Think about real-time AI processing or network management or even smart city infrastructure. These are all dynamic environments. We need systems that can adapt on the fly, reallocate resources and basically make sure everything keeps running smoothly, even when something unexpected happens.
And that's where Marizo's research comes in. He's proposing a new architecture for these multi-agent systems. And the key is using LLMs to enable something called semantic task evaluation. It's almost like giving these systems a super smart foreman who can adjust the plan as needed.
Precisely. Imagine each robot or agent being able to communicate its progress and any challenges it's facing, and not just in some kind of code, but in plain English.
So they're not just mindlessly following orders, they're actively participating in the process. That's pretty amazing when you think about it.
It is. And these LLMs, they act as the brains of the whole operation. They analyze those reports from the agents, they understand the context of each situation, and they can even identify those kind of hidden dependencies between tasks. It allows for a much deeper understanding of what's actually happening within the whole system.
It's like the LLM is a project manager, right? They see the big picture, they connect all the dots, and they make smart decisions about how to best allocate tasks and resources. So how does all of this actually work in practice? I know Marizao's architecture has three main components.
Yes, you've got the specialized agents, first of all. Each one is designed for a specific task. And they don't just perform their duties, but they also generate those language summaries we talked about.
Right, so they're doing and reporting and explaining all at the same time.
Exactly. And then you have the centralized control unit, or the CCU. And this acts as the central hub for all those reports coming in from the agents.
Okay, so the CCU is like the foreman gathering information from the field.
A perfect analogy. And then finally, we have the LLMs. The CCU feeds all that information from the agents into the LLMs. The LLMs analyze all the language summaries, they pull out the key insights, and then they make decisions. Decisions about how to best manage the entire system.
So the LLMs are like a super smart project manager overseeing the whole operation. It's pretty revolutionary, wouldn't you say? Giving these AI systems the ability to basically talk to each other and explain their reasoning in real time.
It's a huge step forward, and it leads to some really exciting potential benefits. Marizal outlines several in his paper: faster task completion, less need for human intervention, more efficient use of resources, just to name a few.
It all sounds very impressive in theory, but I'm really curious about the real-world impact. What kind of difference could this technology actually make? Marizal does mention some specific examples in the paper, right?
He does, yes.
Yeah.
One really compelling example is the ability to handle those simultaneous regional failures. Imagine you have a network of data centers, like the ones that Google or Amazon use, spanning the globe.
Okay, I'm picturing it.
Now imagine that major outages hit multiple regions at once. It could be natural disasters, cyber attacks, any number of things.
Hmm.
In a traditional system, with that static task allocation we talked about, this would be a complete nightmare.
It would be chaos.
Servers in the unaffected regions might just sit there idle, while others are completely overwhelmed, unable to adapt to that sudden shift in workload.
But with Marizao's architecture.
The system could adapt in real time. Those agents would be constantly monitoring the health of all the data centers, sending reports back to the CCU.
So there's a constant stream of updates on what's happening everywhere.
Yes, and the LLMs would be analyzing all that data, figuring out how to redistribute the workload, maybe even suspending certain tasks or rerouting traffic, all to keep the system stable and running.
It's like having a smart air traffic controller who can reroute planes around a storm to make sure everyone gets to their destination safely.
That's a great analogy. And that's the real power of this approach. It's not just about efficiency, it's about resilience. the ability to adapt and overcome those unexpected challenges.
That's incredible. So instead of a catastrophic failure, you have a system that can gracefully adapt and keep things running smoothly. I'm starting to see why this research is getting so much attention. Are there other examples where this approach could be really beneficial?
Absolutely. There are several others. Marizal highlights this potential for anomaly detection in financial systems. And this one's really interesting because it shows how these LLMs can go beyond just understanding data. They can actually extract meaning and insights from human language.
So we're not just talking about crunching numbers anymore. We're talking about AI that can understand the nuances of language like some kind of, I don't know, financial detective.
Exactly. Imagine a system that's constantly monitoring financial transactions for any signs of fraud. But instead of just looking for suspicious patterns in the numbers, these AI agents are also analyzing the language that's associated with each transaction.
Like those descriptions you see on your bank statements, right?
Yeah.
Amazon purchase or Uber ride. It always gives you that little bit of context.
Right. And that context can be incredibly valuable. The LLMs can analyze those descriptions to identify potential red flags that might otherwise be missed. For example, an unusually vague description or the use of certain keywords could raise a red flag.
It's like having an AI detective that can read between the lines, spotting clues that humans might overlook. Fascinating stuff. Could this type of analysis be applied to other areas as well? Beyond finance, I mean.
Oh, absolutely.
Yeah.
Marizal also talks about dynamic network optimization, which is all about managing the flow of data and traffic across these really complex networks, like think about telecommunications systems or even the internet itself.
So keeping everyone connected and making sure things are running smoothly, that's got to be a huge challenge these days with so much data flying around.
It is a massive challenge.
Yeah.
Traditional systems often rely on static rules and predetermined pathways, but in a dynamic environment like the internet, that can lead to congestion, delays, even outages.
Right, because the system can't adapt to sudden changes in traffic patterns or unexpected demands. It's like having a traffic jam because everyone's forced to take the same route.
Exactly. But with Marizal's architecture, the system can analyze real-time data from the network and then make adjustments on the fly. Imagine a smart traffic management system that can reroute cars around accidents or adjust traffic light timing to optimize the flow of vehicles.
That would certainly make my commute a lot less stressful. It sounds like this approach could be applied to any system that deals with a lot of dynamic data. But these LLMs, they're just one piece of the puzzle, right? What about these other emerging technologies that Marizal mentions in the paper? Things like quantum computing and edge computing and AI-driven robotics.
Yeah, he's making the point that the framework he's proposing isn't just about solving today's problems. It's about creating a foundation that can evolve
Mm.
and incorporate these future technologies as they mature.
So it's not just a solution for today, it's a blueprint for tomorrow. Okay, let's dive into some of those technologies a bit. Quantum computing, for example. I have to admit, I'm still trying to wrap my head around that one. It's like these super powerful computers that use quantum mechanics to do calculations, right?
That's the basic idea. Quantum computers have the potential to solve problems that are simply impossible for traditional computers to handle, even supercomputers. Things like simulating complex molecules to design new drugs or breaking the encryption that protects our online data.
That sounds incredibly exciting and a little bit terrifying all at the same time. How would this tie into multi-agent systems, though?
Well, imagine an MAS that has access to the immense power of a quantum computer. It can solve incredibly complex optimization problems in real time. Think about optimizing traffic flow for an entire city or managing the energy grid for an entire country.
It's like giving those super smart AI agents we talked about earlier a brain that's a million times more powerful. The possibilities seem almost limitless. What about edge computing? Where does that fit into all of this?
Well, edge computing is all about bringing the computation and the data storage closer to the source of the data. So instead of relying on these giant data centers, we're talking about distributing that processing power to devices at the edge of the network. Smartphones, sensors in self-driving cars, even tiny devices in our homes and clothes.
So instead of sending all that data back and forth to a central location, it's processed locally. That would make things a lot faster and more efficient, I imagine.
Exactly. And when you combine edge computing with these semantic-driven MAS, you get systems that can make decisions and take actions much more quickly, especially in those time-sensitive situations.
It's like having a reflex, an instant reaction to a stimulus. That brings us to AI-driven robotics, which is where things start to get really futuristic.
Right, we're talking about robots that can learn, adapt, and make decisions on their own without needing humans to program every single step.
I can picture a factory where robots and human workers are collaborating seamlessly. A semantic-driven MAS could coordinate the entire operation, assigning tasks, optimizing workflows, even resolving conflicts. And the robots wouldn't just be following pre-programmed instructions, they could actually understand the context of their tasks and work together as a team.
Exactly. And this type of collaboration between humans and robots has the potential to revolutionize so many industries, from manufacturing and logistics to healthcare and even things like disaster response.
It really is a fascinating glimpse into the future. But Marizel also acknowledges that there are some challenges to overcome before these systems can be widely implemented. He mentions computational demands and integration complexities as two key obstacles. What did he mean by that?
Well, LLMs, as powerful as they are, they can be quite resource intensive, especially when you're dealing with real-time data analysis. It's like having a super smart brain, but it needs a lot of energy to function. So finding ways to make these LLMs more efficient is a major focus of research right now.
It's like trying to run a complex AI system on a smartphone. The technology just isn't quite there yet, so that's one challenge. What about integration complexities?
Well, these systems involve a lot of different components. You've got the agents, the CCU, the LLMs, external data sources, and getting them all to work together seamlessly can be tricky. It's like building a house with materials from different countries, each with its own set of instructions and building kings.
You need a lot of careful planning and coordination to make sure everything fits together properly. Marizao really emphasizes the importance of well-designed architectures and robust middleware to bridge the gaps between these different systems, right?
He does, yes. It's not just about the AI itself, it's about the entire ecosystem that supports it.
It's like building a city for those super smart AI brains to live in. You need roads, power grids, communication networks, all the things that make a city function. These are definitely complex challenges. But it sounds like Marizao is optimistic about the future of this technology.
He seems to think the potential benefits are definitely worth the effort. And it's clear that this research could really change the way we think about and manage these complex systems.
It could. And as we've been talking about all these advancements, it's really struck me just how quickly this field is evolving. I mean, just a few decades ago, the idea of AI systems that could understand language and manage tasks and adapt to dynamic environments, it would have seemed like science fiction.
It's amazing how far we've come. And it makes you wonder what the world will look like in another 10 or 20 or even 50 years. What kind of breakthroughs are just around the corner?
It's exciting and a little bit daunting at the same time. It feels like we're on the cusp of a new era, and it's really up to us to shape that era responsibly.
That's a good point. It's not just about the technology itself, it's about how we use it.
Exactly. Marazao's research is a real testament to human ingenuity, but it also raises some important questions about the role of AI in our lives and how we can make sure these advancements benefit all of humanity.
It's a conversation we need to keep having.
And it's not just a conversation for scientists and engineers either. It's a conversation for everyone, because these technologies are going to impact all of us in one way or another.
Absolutely. The future of AI is not predetermined. We're creating it right now through the choices we make and the actions we take.
I think that's a perfect note to end on. As we continue to explore the potential of AI, it's important to remember that we're all part of this journey. We all have a role to play in shaping the future.
Couldn't agree more. It's been great diving deep into all of this with you.
The pleasure was all mine. And to our listener, thank you for joining us on this deep dive into the world of semantic-driven task allocation and its potential to, well, maybe even reshape our world. We hope you found it as thought-provoking as we did.
And maybe it even sparks some new ideas of your own. Until next time, keep exploring, keep questioning, and keep imagining all the possibilities.
See you next time.